let's say that we have a question about power output, which essentially can be interpreted as a question about how we have the same work in half the time. So an engine performs work W in time T, producing a power T. If the same amount of work is done in half the time, what happens to the power output? So you're going to use the formula for power, which is work divided by time, where P is power, work is work over energy, and T is equal to time. So the proportional form of this is going to be P is proportional to 1 over T. And this is if work is constant, which it is in this case scenario. So then T is transformed into 1/2. And this is going to be an inverse relationship. So P is going to be W over T over 2. So that's just 2 times W over T, which is just 2 times P, which is C. Now let's say we have a question about orbital speed. Okay, so a satellite orbits a planet in a circular orbit of radius r with speed v. If the orbital radius is quadrupled, what happens to the orbital speed? So the concept you need to know is that farther orbits are slower because gravity is weaker. And also, orbital radius, it scales with an inverse square root of radius. So this is represented in the formula of a relation that we can derive from centripetal force. So using centripetal force, we have G times m over r squared is equal to mv squared over r. And that means we can get v is equal to the square root of g m divided by r. And as you can see here, m cancels out, and we can multiply both sides by and then you multiply that by r, and then that cancels out, and then you have another r here, and then that cancels and leaves one r down there, and then you just take the square root, and then that's how you get that. So now to get the proportional form of this, that's just v is proportional to 1 over the root of r, because again those are going to be constants. And now we have to change r into 4r, and we're going to apply the square root, which is essentially going to be the main thing in this relationship. V is going to be v prime is just v times 1 over the square root of 4, and that's just going to be v over 2, so it's actually halved. So that's D. Now let's do a question about orbital period. So a moon orbits a planet in a circular orbit of radius r with period t. If the orbital radius is doubled, what happens to the orbital period? So the concept you have to know for this is that bigger orbit means a longer path and also a slower speed. Therefore, we know that period increases more than linearly. So that means that we can use this specific relationship for orbits around the same planet or star. You can use T is proportional to R divided by 3, to the power of 3 over 2. So where does this come from? This comes from T is equal to 2 pi times R over V. So then we can get that, we can just isolate for V and then divide by T. And then, we can divide by T. And then dividing by T, that cancels out. So then you just get V is just proportional to 1 over the square root of R. And then that means you can get t is proportional to r times the root of r. So then we get that, and this is going to be equal to r times to the power of 3 over 2. So then we change, okay, and then we change, okay, yeah, we change r to double its value. So that means t prime is equal to t times 2 divided by 3 over 2. So that's going to be equal to t times 2 times the root of 2. So that's going to be our answer of D. So let's say we have a question on escape speed. So a planet has mass m and a radius r, giving it escape speed VE. If the planet's mass is quadrupled while its radius remains the same, what happens to the escape speed? So something you need to know is that escape speed is the speed to needed for an object to break free from the gravity that is holding it wherever it is, and it scales with the square root of mass. So what does this mean? So you have the formula VE is equal to the root of 2gm over r, where VE is escape speed, m is planet mass, and r is just the planet radius. Now the proportional form of this is VE is proportional to the root of m, and we are going to change m to 4m. So that means we are applying the square root. So what this means is that VE prime is equal to VE times the root of 4. And that's going to be 2 times VE. Because the square root is 2, and that's going to be A. Now let's say we have a question about speed from energy conservation. So a ball is dropped from rest from a height h and reaches speed v just before hitting the ground. If the drop height is quadrupled, what happens to the final speed of the ball, ignoring air resistance? So what you need to know is that dropping from a higher height means more gravitational potential energy because it's higher up, of course. And which is converted to kinetic energy. So that makes speed square with the square root of height. And this is evident in the formula mgh is equal to 1/2 mv squared. And if we cancel out the m's and we just ignore the constants, then we just get that h is going to be proportional to v squared. And we get that v is proportional to the square root of h by taking the root of both sides. And we can change h to 4 times its value. And then applying the square root, we get that v prime is equal to v times the root of 4, which is just 2v. Now we can move on to our next questions. So let's say we have a question about combined mass and speed change pertaining to kinetic energy. So a cart of mass m moves with speed v and has kinetic energy k. The mass of the cart is tripled while its speed is halved. What is the new kinetic energy in terms of k? So we want to approach this problem with talking about how kinetic energy depends linearly on mass. And what does this mean? Well, we can see this and also quadratically on speed. So what does this mean? So we know that k is equal to 1/2 mv squared. So we can get K is proportional to mv squared. And we can cancel out that 1/2. And m, we have to change m to 3 times its value. So then v is 1/2 of v, because that's halved. And now we get v squared as 1/2 v squared, 1/2 squared times v squared, and that's just equal to 1/4 v squared. Now we can combine all of these factors, and we get k prime is equal to k times 3 times 1/4. That's from here. Or this is from, we just need this. And we get 3/4 times k. And actually, that's actually wrong. This should be 3k/4 as the correct answer. Okay, so let's say we have a question about gravitational force with multiple changes. Two objects attract each other with gravitational force F when separated by distance r. If both masses are doubled and the distance between them is tripled, what is the new force? So a concept we have to know is gravitational force. It scales with product of masses and also inverse square of distances. So where do we get this formula from? We get this from F is equal to G times M and divided by r squared. So then we get F is proportional to M over r squared. So both M's are doubled. So that means the mass factor is going to be 2 times 2, which is equal to 4. And then distance, which is r, is tripled, so it's 3r. So that means distance factor, you essentially analyze it without looking at the m's at all. That's this part. Is this part. 1/3 squared is equal to 1/9. So then you can combine these. F prime is equal to F times 4 times 1/9. That's going to be scaled by 4/9F. That's going to be A. Now, let's say we have a question about speed from an explosive separation. We can use energy reasoning. So, two identical carts are initially at rest on a frictionless surface. A compressed spring between them is released, causing them to fly apart. If the spring compression is doubled, how does the speed of each cart change? Okay, so we know that the formula for spring energy is equal to US, and that's equal to 1/2 kx squared. And from this, we get that US is going to be proportional to x squared because we just cancel out these. And then now we know that the compression is doubled. So that means that we can have US, which is going to be 2 times to the power of 2 times US. And that's going to be equal to 4 times US. And then this is the kinetic energy of each cart. So for each cart, we know that K, and we also know that for each cart, K is going to be proportional to V squared. And now we know that if KE is multiplied by 4, then we get V squared, which becomes 4V squared. And that means V becomes 2 times V after we take the square root. So that means it's doubles. Now let's say we have a question about power with changing force and time. which is the same as distance. Wait, yeah, same as distance. So if time stays the same, then power changes same way as work. What does this mean? So we have P is equal to W over T. And we also know that work is parallel to motion, right? From this. Because it has to be like in the same direction. So it's parallel in the same direction. So that means and in this question, we double force to 2F. And D, we find 1/2 of it. So therefore, we have that W prime is equal to 2F times 1/2 D. And that's equal to F times D, which is equal to W. And because we know that time is unchanged, that means that power is unchanged as well. So that means we have P prime is equal to W prime over T, which is W over T, which is just P. It's the same as before, same power. So let's say we have a question about height and speed with energy conservation. A ball is launched vertically upward with an initial speed of v, reaching a maximum height h. If the launch speed is tripled, what happens to the maximum height reached? So maximum height, it comes from energy. And initial kinetic energy will become gravitational potential energy. So using the idea of energy conservation, we know that kinetic energy is going to be equal to potential energy. And that way we can set 1/2 mv squared equal to mgh. And then we just see that these cancel out. We see that m and g cancel out and these cancel out. So we're not paying attention to those, okay? So h is going to be proportional to v squared. So if we triple speed to this, then we have h3 squared times h, and that's going to be equal to 9h. So your answer is C. So let's say we have a question about a spring mass system with combined variables, and a block is compressed by a spring a distance x when moving at speed v. If the mass of the block is quadrupled and its speed is halved, what happens to the maximum compression of the spring? So what you need to know is that at max compression, this means that all kinetic energy has become spring energy. And where do we get this from? Well, that's because when it's at its maximum compression, that means that all of the kinetic energy, it's at its maximum potential. So that means that if it can't be compressed anymore, it has no more potential to release energy upon being uncoiled. So that's why it's at its max. All the kinetic energy is basically gone at that moment, and it's been converted. So now we can use the idea again of law of conservation, which is essentially, you can think of it as conversion, because everything has been converted, you know? And you can set kinetic energy equal to spring energy. So you have 1/2 mv squared, and that's going to equal to 1/2 kx squared. So yeah, you can just cancel that out. So then, and you can also cancel these two out too. So you just are left with, we'll just keep that. So we'll get x squared is proportional to mv squared, and x is proportional to the square root of mv squared. So then we want to change m to 4 times its value and also v to 1/2 its value. So we get v squared is 1 over 4 times v squared. And then we can multiply the inside. So we have mv squared, and that's going to be 4m times 1 over 4v squared. And that's going to equal to mv squared. And x is unchanged. Therefore, x is unchanged. Therefore, we just have x. Now, let's say we have a question about work energy with variable force this time. So work, we need to know that work is linear in force and direction, which is from W equals to F times D. So a force does work W on an object as it moves a distance D. If a force is halved and the distance is quadrupled, what happens to the work done? So now we can change F to 1/2 F and D to 4D. So that means W prime is going to be equal to 1/2 times F times 4 times D, which is just 2FD, which is just equal to 2 times the work. So that's just going to be D. Let's say we have a question about power and speed with the same force. A constant force pulls an object at speed v, producing power P. If the speed of the object is tripled while the force remains constant, what happens to the power output? So we know that power can be written as P is equal to F times V, and force is going to be parallel to V, and also speed is going to be constant. So if F is constant and V is tripled, then we have P prime is equal to F times 3V, which is just 3FV, and that's just equal to 3 times the power. So that's going to be C. Let's say we have a question about orbital speed versus escape speed when radius is doubled and the mass is going to be constant. So we have a satellite that orbits a planet just above its surface with orbital speed v initial. The escape speed from the planet's surface is VE, which is V, yeah. If the planet's radius is doubled while its mass remains constant, how does the ratio of V initial over escape speed change? So what you need to know is that orbital speed near the surface is going to be V initial is equal to the square root of GM divided by R. And also you need to know that the formula for escape speed is just VE, which is equal to 2 times GM over R. So we can take the ratio of this, which is going to be GM over R divided by 2GM over R. That's going to be 1 over the square root of 2. Because we can see that those cancel out, just left with that. So we know that cancels. So that means that if R changes, which is the mass constant, also the mass is constant, and that's changes, that means both speeds change the same way, basically. So that means that the answer is C. It remains the same. And let's move on to our final question. If the ramp height is quadrupled, so energy partition. A block slides down a frictionless ramp from height h, reaching speed v at the bottom. If the height of the ramp is quadrupled, how does kinetic energy at the bottom change? So at the top, we know that U is equal to mgh, right? And we know that at the bottom, kinetic energy is equal to mgh because of conservation. So that means that kinetic energy at the bottom is going to be proportional to the height. And we also know that if we want to find if it's quadrupled, so that means that k is going to be also quadrupled because they're proportional. Okay.